In this class, we are going to study about the evolution of electronics and impact of electronics in industry and society. Let us start with the evolution of electronics. The evolution started in 1904 with the simplest basic device, that is vacuum tube. It was invented by scientist John Fleming. The construction of this vacuum tube diode you can see in this picture. In the construction you see basic plates, that is cathode, anode, and you can see electrons between this cathode and anode. This vacuum tube, it was based on the principle of thermionic emission. That means when the cathode was supplied with the energy, electrons emitted from this cathode, and when a positive voltage is applied to plate or anode, then these electrons get attracted towards the anode and current flows in the device. So this basic vacuum tube device, that is diode, it was further changed into its advanced versions like triode, tetrode, pentode. In 1907, De Forest invented the triode by inserting a third electrode between cathode and anode. After this, tetrode, pentode were also introduced. What is the use of this vacuum tube at that time? This vacuum tube was used in most important device at that time. That device was first computer, that is ENIAC computer. You can see the picture of vacuum tubes over here. The glass tube is there, and inside glass tube, cathode, anode and control grid is there. Grid is inserted between anode and cathode to control the flow of electrons between cathode and anode. So this important device, that is vacuum tube, it was used in the ENIAC computer, which was developed in 1946 at the University of Pennsylvania. What was so special about this ENIAC computer? At that time it was called as giant brain by the press. It was 1,000 times faster than earlier electromechanical computer. If you see how it is constructed, then it is constructed with approximately 17,468 vacuum tubes, number of crystal diodes, relays, basic components, resistors, capacitors, switches. So vacuum tube was the dominating device that was used inside this computer. This computer required large space also at that time, and it consumed 150 kilowatt of power. That was too much. Huge power was consumed. And input was possible to give it to that particular computer using card reader. Now because of this vacuum tube, as it takes more space, it is heavy and its power consumption is also large. Whatever device was constructed at that time using this vacuum tube, that was also huge and power consumption was also more. So this vacuum tube, as it was a bulky device, later it was replaced by a new device which significantly reduced power consumption, and that new device was first transistor. That is, transistor replaced vacuum tube. In 1947, at Bell Labs, the first transistor was invented. And this first transistor was point contact transistor, and later it was replaced by a junction transistor, especially we call it as a bipolar junction transistor. Further, lot of changes took place in this transistor technology also. Transistor was replaced by field effect transistor. Further, metal oxide semiconductor field effect transistor, that is MOSFET, then different versions of MOSFET, that is CMOS, PMOS, NMOS and so on. So after vacuum tube, transistor was invented. Using discrete transistor, number of electronic circuits were built and used at that time. But the major change was this transistor was used as the part of new technology or new device, that was integrated circuit or IC. So first IC was constructed or fabricated using bipolar junction transistor, resistor and capacitor at Texas Instruments. Later, as bipolar junction transistor BJT was replaced by MOSFET, that is metal oxide semiconductor field effect transistor, and CMOS, PMOS, NMOS, then IC technology also changed because of this MOSFETs, and then IC era started. So you can see here just summary of this evolution of electronics. Initially it was vacuum tubes. Then vacuum tube, it was bulky, it was replaced by transistor. In the transistor again revolution took place and it was BJT, that is bipolar junction transistor, then field effect transistor, then metal oxide field effect transistor, then CMOS complementary metal oxide semiconductor field effect transistor and so on. So this changed the IC technology also. So how was the change in IC technology? IC technology change was about integrating how many gates or transistors you are putting on one IC. So according to that integration, it was SSI, that is small scale integration technology, then medium scale integration technology, then large scale integration technology, then VLSI, very large scale integration technology, and ULSI, ultra large scale integration technology. What this technology indicates, whenever it is a small scale integration, then number of gates on the IC are less than 10. Whenever the number of gates are between 10 to 100, then it is MSI, that is medium scale integration. So if you take simple logic gates, that is AND gate, OR gate, then it belongs to SSI technology, that is small scale integration IC technology. If you take ICs like decoder, multiplexer, then these ICs belongs to MSI, that is medium scale integration technology. Then came LSI, that is large scale integration technology. In this, number of gates on one IC, that is between greater than 100 and less than 1000. And whenever greater than 1000 or more and more number of gates are put on one IC, then that technology we call it as a VLSI, very large scale integration technology. And further it was ULSI, that is ultra large scale integration. We call ULSI also by same name, that is VLSI. No difference much more between VLSI and ULSI. Both indicates that there are billions and billions of transistors or gates on one IC. So where this VLSI technology is used? Everywhere now, in computers, in microcontroller, microprocessor kits, all the processors, they were developed using this VLSI technology. So if you see this evolution of basic electronic devices, because of this evolution, parallel technology evolution took place in microprocessor device and in computer generations also. So because of this vacuum tubes to VLSI technology, parallel technology evolution in the microprocessor was initially 4-bit microprocessor was there. Then 4-bit, that is 4004, Intel introduced that 4-bit microprocessors. It was used as a calculator. Then Intel invented next 8-bit microprocessor, that was 8080, and further version was 8085 microprocessor. That was used as a CPU in many microprocessor based systems. Then 8-bit processor was replaced by 16-bit processor. So 16-bit processors where popular processor was 80286. After 885 it was 8086, then different versions 8086, 80186, 80286, then 80386, 486, like this. So what it changed? 80286 it was 16-bit, then 80386 was introduced, that was 32-bit processor, then 64-bit processors. Like this, microprocessor technology also changed, and this microprocessor was used as a CPU in different computers. So computer generations also parallelly evolved because of this evolution of electronics in microprocessor technology. So how many computer generations are there? There are 5 computer generations. So fifth computer generation is today's computer generation, which involves fast processors along with artificial intelligence techniques. As we see evolution in microprocessor and parallel evolution in computer generations, similar evolution is also observed in communication technology, that is communication electronics. So how was this evolution started? Initially there was an invention of telegraph for communication. Then later telegraph was replaced by most popular device, that is telephone at Bell Labs. That was wired telephone. Then that wired telephone later was used for data communication. Further, that wired technology was changed into wireless technology. Wireless technology was possible because of use of radio waves, that is electromagnetic waves. So wireless telegraph was invented. Then complete radio wave communication came into picture, and this radio wave communication changed drastically the entertainment field, that is radio communication and television communication. Lot of changes took place in television communication, that is TV. Monochrome TV was there, that is black and white. Then came color TV. Then lot of changes took place in the monitor of this TV or screen of this TV. So lot of technologies further introduced into this TV or entertainment field. Then radar technology of communication came. Further satellite communication was launched. Besides this basic communication, parallel another communication was wired telephone, then cordless phone, then cell phones. Among cell phones came smartphones and so on. So because of changes in electronics, continuously other technologies are also changing, and this change in the technology is making our life more and more easy. So we can summarize over here about evolution. Just we can see that electronics evolution has changed the world drastically. It has lot of impact on industry as well as on the society. If you see impact of electronics on industry, then every industrial sector that belongs to electronics is changed tremendously. It is consumer electronics, industrial electronics, communication electronics, satellite communication, mobile communication, electronic communication applications in defense, medical electronics technology, information technology, IT and computer technology. So there is a huge change in all these electronic sectors because of changes in the basic device technology in electronics. So lot of industrial revolution take place, and this has enhanced the production, this has enhanced overall all the industrial processes, and most of the industries are completely automated because of this electronics evolution. So this is the biggest impact of electronics on the industry. What are the benefits or what are the advantages that we get because of this electronics on the industry? So if you see benefits, then we can see that due to automation, manual work in the industry is really reduced. And because of automation, processing has become very fast. Then safety is provided in the industry. Accuracy, precision, overall efficiency of all the industrial work and processes is increased. Business is expanded on the large scale. Economy is also improved. Because of fast wired and wireless communication and complete digitization, it changed the world completely. Now it is very easy for anybody to access data from any location and process it and send it to any destination. So if you see benefits, then lot of benefits are there. So there is a huge impact of electronics on the industry. But besides this benefits, there are some drawbacks that we have to face. So drawbacks are few. Those are manpower is reduced because of automation, and because of less physical efforts or less works for the human beings, health issues are increased. Similar to industry, the evolution of electronics has made more impact on the society also. Now for us, because of electronics and automation, it is very easy and it is very easy for us to manage the operations by sitting at home. Because of this electronics and communication, it is possible for us to operate anything as per our wish by sitting at home. We do not have to physically go to that particular location and operate the thing. Means what? Because of electronics, overall quality of human life is improved. There is an improvement in education, literacy. It is very easy for us to handle financial or money matters. The overall automation has provided lot of comfort to us. We can do easy online transactions. Our overall life is easy and comfortable. Time and energy is saved. World has come closer. We have fast access to everything what we want. So this is overall impact of electronics on society. But as I said, one drawback is because of less physical efforts or because of more comfort, human beings are becoming more and more idle, and so health issues are raised. So just we have seen that evolution of electronics and impact of this electronics on industry and society. Here is a simple and small activity for you. You study any industry with and without automation. Means take any industry in which earlier there was no automation, and later again study the same industry when automation was applied in the industry, and find out what changes you feel because of automation. So you will have to mention your findings about this industrial study. There is one assignment for you. Two questions are there. First is explain in detail the overall impact of electronics on the industry with suitable examples. And second question is explain the overall impact of electronics on the society. So I conclude over here what we studied today, that is evolution of electronics right from vacuum tubes till VLSI technology today. Then we have seen parallel change in the computer generations and overall impact of electronics on industry and society. Thank you.